All right, back in business here. So, hopefully you had a chance to really dive into this and dissect some of this information. There are some parallel lines on there. BC was parallel with UG. So that pair of parallel lines gave you some angles that you can use later on. Hopefully you recognize that angle U is congruent to angle, and I'm going to say B out loud, even though I know I've got to clarify whether it's B, B, or B, or B, or B, or B. Which of these B's? There's 1, 2, 3, 4, 5. There's at least 6 different angles that have had B. And the correct one would be ABC or CBA. And in class, it's what kind of angles are they? And of course, Kennedy would very clearly say those are corresponding angles. And everyone knows Kennedy's right, of course. That's one piece of the puzzle. So you got a pair of corresponding angles. If you're not doing this, you're making your life harder. If you know it's true, mark it. Mark the information on the drawing. That way you know one step closer to side angle side. I'm one step closer to angle side, or whichever theorem it's headed towards. Second piece of information is BG bisects UA. BG, this thing, bisects UA. People say, "Oh, that doesn't look like." No, it doesn't look right because this angle is different here. Well, it's saying it's bisecting a length. This length is getting cut in half, which means that this thing has to be congruent to that. I can take a pair of scissors and chop a segment. Whoops. Or I can throw the marker across the room and have it smash the floor and bisect on the ground, and the angles of that scissors be different on there. So hopefully this conclusion makes sense. Looks like I need that black marker again. Only minor damage. AB, congruent to BU or UB. And I've got pair of angles, pair of sides. 2 out of 3 done. Don't skip the last given on here. ACB, that angle was congruent to BGU. And there's your 3 parts. You can see it's an angle side example. Oh, there it is. And I can get those. Whoops. I should put this in here though. ACB equals angle BGU. And if I was in class, somebody would ask a really good question, say, can this be a congruent sign? Absolutely. I kind of use congruence and equality interchangeably, just like I did in this one a minute ago. Perfectly fine to do that for our class. But you need the angle symbols. You need to talk about angles here because the next step, I'm later on talking about the triangles, which is different. Triangle ABC, the red triangle, is congruent to bug, correct letter order on there, by angle side. And you cannot call this angle side angle. Sorry, Asa, you can't just use it every time. You can't call it angle side angle because in this proof, I didn't talk about this angle over here. Now, if I knew these were parallel, I could use these as corresponding angles, but I didn't know that these were parallel. So if the proof ends up at angle side, it's got to show that above. I've got to actually have those specific angles on there. There's a way to do it like this, but it adds more steps to the proof, so you probably don't want to do that. Asa, don't do angle side angle every time. All right, these ones on the back are pretty nice. See if you can conclude that any triangles are congruent on that one. Good spot to pause and go for it. And, some people will be focused on these little triangles right here. And I'll ask in class, is there anything else they have congruent besides those 2 given angles? Correct, they have vertical angles right here, which gives you angle. That's all it gives you. There's no direct way to get these 2 triangles congruent. Angle is not enough. However, there are 2 triangles in this boomerang thing that sort of overlap each other. This top angle is a shared angle. Usually we talk about shared sides, like this is a shared side. The shared angle thing also works. So this is an angle. I'll show it from here. An angle, and a side congruent to an angle, and a side on there. It's kind of hard to see it. But if you consider that triangle with the one that it overlaps, it's easier to see. And if it helps you, separate them and redraw them on there. Oh, some information has already come up on this one here. Some arrows on there. Tells you that these two are parallel. I don't know anything about those. I'm also going to add in these little marks, which tell you those are congruent. That is enough information to prove those two triangles are congruent. So I'll state the major reasons, which means you're kind of setting up a proof, but I'm not giving you the letters to actually be able to write the whole proof. Again, probably pause it, see if you can get that one. So again, I'm looking, when I see parallel lines, I'm looking for corresponding angles, alternate interiors, alternate exteriors, or same side interiors. In this case, here's the parallel lines with a transversal here, which gives me a pair of alternate interiors. And in class, I'd say, well, is it the one on the left or the right over here? Is it the one on the left or the right up here? And people would probably correctly identify it's the one on the left here and the one on the right there. Add on the shared side, and you've got conclusions on there. There's a side angle side congruent to a side angle inside. Now, the other major reasons would be why that angle is congruent to that angle, which of course would be a pair of alternate interiors, and why this is congruent to itself, which of course would be a reflexive side. So, this proof would be like maybe one or two givens, followed by three logical conclusions you draw after that. Next proof. Again, you probably should add these little lines on your paper. So we have proper grammar on there. At the end of this, I'm going to prove, this is typical that they'll tell you the triangles you're trying to prove are congruent. ABC, congruent to DEC, that tells you this is not a reflection. This is not being flipped over here. This is a rotation. AB is being rotated to get to DE. AB and DE are the same. All the givens are there. Go for it. I'm going to hit pause on this one. This looks like a lot like other ones on the previous section. Hopefully you're an expert at doing this, feeling like you're getting closer to being an expert at doing this at this point. Now, be careful. BE is the bully here. This is the subject of the sentence. AD is the direct object. AD is getting a beat out of it here. BE is doing the bisecting. That's important. This one is picking on that one. This is the one that got chopped. Important conclusion to draw from that. Hopefully you've got that somewhere on your proof. The other thing I'm going to mark on the drawing, if I read givens, I'm going to mark them so I can see them. Another thing you probably would conclude is that there's vertical angles that are congruent. If you have vertical angles, they're usually helpful. And the last thing, the third part, and this is before I've even written anything. Sometimes I'll do a proof like this. I'll read and mark things. Some people like to read, write, mark, and kind of work the triangle here of reading, writing, and marking. Kind of go back and forth between the visual. That's another strategy. Now I know what theorem I'm going to go for. I've got an angle and angle aside, angle and side. I can prove these things are congruent. Just a question of getting it all written down on here. So the first given I read, bingo, gave me those two parts being congruent. I recognize there were vertical angles. That's a major step in the proof. And then I've got to name these with three letters, BCA. You can say it's DCE or ECD, not super important, as long as you know C is the vertex of that angle and you're not naming the wrong angle. And the last piece is the actual triangles. So, yes, you have to take this information and write it right there. Yes, you definitely have to take this information and this information and rewrite it right there. Yes. Write it. On the previous quiz that you took before we left, some of you didn't restate givens. If you don't restate them, it's like they didn't even happen. It's like they're not there. It's like, and there's lots of people that don't read directions. So unless you say, hey, the directions are important, and here's why they're important, because bisect means that these two parts have to be equal. Unless you take that step, that process, someone else might go, how did you do it? I don't understand how you did it. And they're looking at you like this, and they're like, what's going on? And you went, Well, you just had to read that sentence right there, and you're going, well, why didn't you tell me that? Tell me it, write it here. So make sure you write those givens down on here. Good habit. Last one. And I'll let you label the drawing here. There is no more given information. So you should be able to pause this and finish that one. So, talking about Zev here, VIP, very important person here. Zev is an isosceles triangle. I is the vertex. That's telling you good information. DP and KV are congruent. I'd be marking that stuff up as I read through this. Good habit. Read, mark, start writing down. Read, mark, start writing down your conclusions and why you're making those conclusions. Now, if you understand this word, there's one logical conclusion you come up with. If you think about that word a little more, there's a second conclusion you come up with. And there's slightly different reasons for those. If you read that word, the next conclusion you probably should come up with is that VI is congruent to IP. Now, if this wasn't here and I told you, hey, VI and PI are congruent, you could come up with another conclusion. And that conclusion would be about that angle and that angle. If I is the vertex angle, these are the base angles, and you know base angles are congruent. So there's some given information. I understand what isosceles means. I understand isosceles also means angles are congruent. There's a third step in there. And all of a sudden, I've got a side, an angle, and a side congruent to a side, an angle, and a side. Dip. And those are the triangles I'm looking at. DIP and VIK. Right, DIP. No, KIV would be the correct letter order on the other one. Oh, and of course, you saw this was not a good idea. They have different colors. I want to make sure my colorblind friends can also read that. Now, the blue stuff came from just knowing what that word means. I had to think a little bit more about V and P. The reason these are congruent is not because of the definition of isosceles. It's because there's a theorem that also says the angles will be congruent. That's the isosceles triangle theorem. It's important to delineate between those two. If you forgot this was the theorem, you would just write a sentence. Isosceles triangles also have congruent angles. It's perfectly fine to write a sentence. Isosceles triangles have two congruent sides. That's how you could clarify both of those without just referencing some theorem that was in your notes somewhere. You just write a sentence explaining what you're thinking on there, why you're thinking that. Then I've got my congruent triangles by side angle side. And yes, absolutely, Zev is isosceles. Got to restate it. Those two givens have to be in here. Got to put them in there. They've got to be entered into information because you can't get any of these conclusions right here without that information. So, like I said, hopefully you've already tried this one. If you haven't, you can certainly go back and do that one. The next assignment that goes along with this is that part C, and it's appropriately named Fun Work. Enjoy.